So here we have another example. We are saying that so we are going to go through the example to see understand the information in it before you even solve it, right? So you see that we have a metal element lamp, right? So it's basically like a bulb, right? The old bulb, the fluorescent ones. So you have something like this, just not part, but just to make sure you understand what's happening. You have some wires, and then you have some wires like this. You have something here, right? So this here is the metal filament we are talking about, right? Okay, and then is you are saying that it has a ratings of this. So basically, this watt here means this is power, right? Right, and then this is the voltage, right? Okay, and then we know power. Right that later. You know power. Okay, let's write power is equal to I squared R, right? Or basically IV, right? So that's power IV. Okay, and then the thing is connected in series with a capacitor, right? And then this is the source. Across the source, 230 volts, 50 hertz, right? So now for problems like this, it becomes easier when you simplify the whole circuit, right? So you see we have a filament, right? Basically a resistor, right? And then a capacitor in series, right? So you have this connected along. So since it's AC, have a sinusoidal voltage source, right? So we have the values have been given, right? And then we have this. Okay. So now the problem is that we have to find the capacitance required. Since it's a closed circuit, there should be some capacitance required for that will happen for everything to maintain, for everything to be in balance, right? But let's see. So clearly looking at this, there are two ways to get a so now we've seen everything in the problem. We start by solving it. There are two ways to get a capacitance, right? So we've seen that we have one that's of this sort. We have this, it's a function of time, instantaneous, and then we have translagen the V. So we have C, and then we have the V dt, right? So our capacitance appears here. Right? Then we have another one where we have V C is equal to I C and then XC, right? And then our capacitance appears in this one because why we have XC to be equal to 2 minutes to be equal to 1 on 2 pi F and C. So our C appears here, right? At this side. Right. So we can use any of this, but looking at the problem given, we are not given the what do you call it, the voltage as a function of time, right? So we cannot use this one. The one that we can use is this, right? And to do that, what do we need? You know what we need. So frequency is given, this, right? The only thing that we need to find the voltage and the current, right? Okay. By looking at the circuit again, let's see. So what do we need? We need voltage and current, right? Okay. So basically, I need to find the XC, right? It's XC, right? So that's VC on IC, right? Okay. So now let's see. How do we find VC? How do we find IC? So we know clearly that the. So now let's go to the circuit. I think we should redraw it. Okay. Let's redraw it. Let's see. So we have a resistor, we have a capacitor, and we have a voltage source. Okay. So resistor. Oh, so you can skip the drawing part if you already have the diagram. Then we have a capacitor, and then we have a voltage source. Okay, so that's sinusoidal. Okay. Okay. Okay, so we have this. Okay, So then now we are supposed to find XC, but then we have some things that we need to find. That we need VC and IC. Right, so let's see. Clearly we know that if there's a voltage source and then the current is moving, right, moving any of this, so let's say it's moving this way, right, if it's current, the same current to pass through this, so that will mean that I R is equal to what? IC, right? But then if it's voltage, mean there'll be a voltage drop, right? But then let's look at what we are given. Looking at it very well, now let's see. Let's write this, that the VR is not equal to the VC, right? And which of these ones can we find easily first? Right, so let's look at what we have. Okay, this one, VR is not equal to VC, right? Not equal to. Now let's move up, right? So let's see. We're not giving anything about the capacitor, right? But we need either voltage or current to go on, right? But the one that is easy to find is that when we have that of the IR, when we have IR, we'll have what? IC, right? So let's go ahead and try and find IR, right? We have nothing about the capacitor, so let's see. Yes, we have the power. Let's make it P. The power P. So our power, which is the P across the R, right, being equal to, let's make it a simple so it's more understandable. The power across the resistor is equal to 750, right? Watts. But then we want the current, and we know power is equal to I squared R, which is the same as IV, right? And then you want the what's the name? The current, right? Which is the IR here that we are looking for, right? So to do that, what do? We will have to divide this power by the voltage, and then this will give us our I here, right? This is our I. Now let's go to this, right? So that's what we do. So we have the power, which is this. We have the voltage across it, right? So that's for our I. Our IR, which is the same, seem to be our IC because they are in series, will give us power 750, and then the voltage is 100, right? And that gives us 7.5 amperes, right? Right. What are we trying to do? We said we are trying to find XC, right? We found IC. We found IC. Now what do we need? We need VC, right? So what do we do? So this is the voltage source. If it's coming, the voltage is coming. It will be after it passes through this when it passes through this resistor here, there'll be a voltage drop, isn't it? There'll be a voltage drop. If this were to be DC, we would have just subtracted this straightforward, right? If this were to be DC circuit, we would have just said that the voltage across the capacitor is equal to, what's the name, the 230 minus the 100 voltage drop, right? And we'll have, so this for DC. If these were DC values, right? But here's the case, we won't do it this way, right? We have to do it the AC way. So AC, this is what we are doing. So that's how we do it. We get to know that they are vectors, right? So clearly we see that the V is equal to, basically V squared is equal to VR, right? And then we have plus VL minus VC squared, right? But then in this case, we don't have any inductor in the circuit, so this is out, right? So we end up with this. We end up with VC squared is equal to VR plus squared. This is a squared, right? Plus minus VC squared, right? So this, it takes care of this minus. Okay. So in order for us to get our VC, we will use square root, right? And then we have V squared minus V L squared, right? Yeah, so that's what we have, and this will give us our the VC that we are looking for, right? This will give us the VC. Excuse me. Right, so this gives us a VC, right? This gives us a VC. So in terms, you just say there's a magnitude of the VC, right? Okay. So now let's see. Do we have the V, which is from the voltage source? That's 230, right? So that's square root of 230 squared. Put some bracket just to be safe. We have the voltage across the VR. Let's see. Do we have that? Yeah, we have that. It was given. So that's the 100 volts, right? 100 squared, right? So let's see what we get for this. Okay. So basically, you should be able to, whenever you see the question, you should be able to go through it and know, oh, you need this, you need that, you need that. You should be able to analyze the question even before you start solving anything, right? It makes the work easier instead of just rushing through it, right? If you understand what you need to get what you want, then you should be able to do it. So 230 squared minus 100 squared, yeah, and that gives us the VC of 207.1232 volts, right? Okay, so now that we have this, then meaning that we can go straight forward and find our XC, right? So XC will be equal to VC on IC. Well, we know IC is equal to IR, right? So let's see, what do we have? You have VC to be this. So that's 207.1232, right? That's a VC, and then IC. What did we get? 7.5, right? 0.5, and that gives us 27.6164 ohms. We have XC. We can move on and say that's our C. We know XC is equal to 102 WC is the same as 102 by F and C, right? So this will mean that our C is equal to 102 by F and then XC. So let's see what we get for that. So 1, 2 pi. Frequency was 50. Let's confirm. Yeah, 50 hertz. Yes. Then RXC, we have 27.6164. Okay, so this gives us this value 0.001152. 1152. If we are trying to see, let's see what we can change to generate figure. What do we do? Okay, see. Let's see if we can do micro. Right, so that's times 10 to the power 6. Yeah, so it's micro, so that will give us 115.2611 15.2611 microfarad. Yeah. So that's it for the first part of the question, right? That's the A. What do you need to find next? The B is asking us to find the phase difference, the phase angle, right, between the current and the voltage. This is something that we've done. Let's see. We know clearly that because we have two elements, right? We have what's the name? We have this is basically a combination of the inductor and then the resistor, right? So there should be a way to go about this. So let's see. Okay. So because we are having a resistor and inductor, this has to be. So for the resistor part, it will be this way. We have the voltage here. The voltage, right? This is V R, and I have the current. The current in line, right? We're just trying to simplify the whole circuit, right? This is the current, the R, right? What else? Then for when it comes to the inductor, the current is still the same as, so let's see. IR is equal to IC, so the state is here. But then the voltage is different. The voltage lags, so that will be here. And this is VC, right? And angle between this is 90. Between these two is 90. Right? 90 degrees. But the voltage from the source won't be in line with any of the voltage sources here. Right? It's actually just the vector sum of the VR and the VC. Right? So the voltage source, the one from the voltage supply, will be somewhere here. We don't know the phase angle yet, so that's what we're trying to find. Right? So we're trying to find what this V, right? Which you see, let's say resultant. Looks like this one. So let's just make it this. Yeah, let's just write it this way. Yeah. So this is the voltage from the source. Right, the voltage from the source. Okay. So before we find, so basically it wants us to find the phase angle between what they say, the voltage and then the voltage and the current, right? The current and the voltage supply. So it says between the current, let's go back. The current, the phase angle between the current and the voltage, right? And then here's a case that the voltage that they are referring to is not specifically the voltage from across the resistor and not the voltage across the capacitor, right? But the voltage from the supply, right? Because that's the only main voltage source here. We don't see the others directly. Let's see. This is a circuit, right? These are the values that we see directly. You don't see the VC, you don't see the VR, and you don't see the VC directly. Right? This is the one that this is the voltage that we see, like clearly, is it clearly stated. So that's the voltage that is referring to, right? So we want us to find the phase angle between the current, which is the I, we know is IR, which is the same as the IC, they are the same. We want us to find the phase angle between them. So that will be from here to here, right? Let's write it as this. So the phase angle we're looking for is this side, right? This side. Okay. So that's what we're looking for. All right. So that's how we go about it. Now to do that, we need two things. There are a lot of ways to find this. Right? It's either we use, so let's see, when we are trying to find this phase angle, trying to find the phase angle, we need it's either we need VC, we use VC and what VR, or for the same. So let's see, let's write it this way. This capacitor here, this capacitor, and this is for resistor. Then we use VCVR, or we use R, and then we use what, XC. Right. So any of them will work, but we'll try both of them. So let's see. So you have to find the theta. We do tan inverse of, because see we have a triangle here, right? So we'll have a XC here, and we'll have R here, right? Okay. So now to do that, any of these two will work. So we have VC, and then we have what, VR, which should give us the same value as tan inverse of so XC and R. So we'll point both of them and see if we get the same value. Right. So let's see. Right. So VC, what do we have for that? VC. That's 207.1232, and we have for VR, that's 100. Yes, 100. And that gives us 100. Okay, and that gives us 64.2285 degrees. And let's see, when we do using XC and R, becomes 750 on 7.5 squared. Alright, so R is 40 on 3. You could have also used V to go to IR, right? Because we have VR and then we have what, IR, right? Just the same way. Just be able to know what you need, right? So let's see. You have to find to confirm. So we've confirmed that this works. We are now trying to confirm if this. So we've confirmed this. We are now trying to check this, right? So let's see. So tan inverse, right? XC was 27.6164, and then R, which we found now, is 40 on 3. So 40 on 3, yeah, and it gives us the same thing. So now it's confirmed. So now I'm still getting this 64.2285. Yes, so this is confirmed as well. So that's it.